Hello everybody, and welcome to the PoorMansChemist. In this video, we are going to be attempting to make benzaldehyde from benzyl alcohol using Bispyridinesilver 1 permanganate as the oxidizer and an anhydrous benzene solution. So, the paper that I'm working on says that we should be able to get a 100% yield in 30 minutes. Making this a very superior method if it actually works. It does have a downside, and that's, at least on a small scale, is the ratio of everything that goes into the reaction. It takes 30 milliliters of benzene for every 0.01 moles of benzyl alcohol, which is 0.01 moles is 1.08 grams of benzyl alcohol. And we need 0.01 moles of the Bispyridinesilver 1 permanganate, which is 3.85 grams. Obviously, I mean, yeah, the mass of the oxidizing reagent is kind of high, but again, 100% yield in 30 minutes. I think that if you actually scale this fucker up, like if you were to do a larger scale prep, you might be able to fool with those ratios and get away with it. But since I only had about like 65 milliliters of benzene left after I made the reagent, we're not going to try anything here. We're just going to do it exactly the way the paper says. Now, obviously, we'll only get a few grams of benzaldehyde, but it will prove the concept. And because this is a proper organic synthesis, we are going to purify our product, at least mostly, and then we are going to characterize it by precipitating out the benzaldehyde as the dinitrophenylhydrazone. This is something like, you know, if you take organic chemistry in college, man, everybody will work with dinitrophenylhydrazones. Way back in the day, before modern analytical equipment, you could create the dinitrophenylhydrazone of any carbonyl compound, well, aldehyde or a ketone. And these compounds, these dinitrophenylhydrazone derivatives, all have sharp characteristic melting points. Now, it just so happens that I have a few milliliters of benzaldehyde left that's actually reagent grade. So what I thought we would do is do the prep, create the dinitrophenylhydrazone of the benzaldehyde from the prep, create the dinitrophenylhydrazone of stuff that we know is reagent grade benzaldehyde, and then we will filter both out, dry them, and then compare the melting points on both of them. If they are identical, that is immutable fucking proof that our reaction worked. Now, our reaction does have one other disadvantage in that, and this is a general feature of oxidizing alcohols to or primary alcohols to aldehydes, in that water must be absolutely excluded. If there is water in the reaction, it's going to the oxidation is not going to stop at the aldehyde. It's going to go all the way to the carboxylic acid, in which case we would get benzoic acid. Benzoic acid will not form a dinitrophenylhydrazone. And neither will benzyl alcohol. So we'll know if this prep works or if it doesn't. Anyway, well, now that we've got all the preliminary information out of the way, like I said, the benzyl alcohol, our 2 milliliters of it is already in there. And I'm going to go add in the reagent, and we're going to get this party started. This stuff is still a little bit damp, but it should be with benzene, not water. Okay, here comes the fun part. Okay, look you. I'm sorry if you guys can't see that. Shit. Yeah, some of it's stuck to the beaker, all right. Are we still focused? You guys seeing all this? Okay, I was right. We did lose a little bit on the beaker. I'm glad I compensated for that. Okay. Now we're going to turn on the Reflux. I am going to wrap this bitch in some foil to try to protect the reagent from light. All right, there we go. That's as good as it's going to get. Oh, come on, damn it. Okay. All right. Here we go. Fingers crossed. Whoa. I just opened this up to try to clean a little bit of this stuff off the side. I can already smell the benzaldehyde. This thing has been going for all of like 2 minutes. Holy shit. Whoa. Wow. Damn. I knew it'd be good. I didn't think it'd be this good. All right, people. It has been half an hour. Doesn't appear to be any visible change. Although, like I said, I got a serious whiff of benzaldehyde when I took the condenser off for a second to try to clean this neck, which obviously I was unsuccessful. I am going to put the foil back on it just because I don't know what's going on in there. I'm not going to worry about light sensitivity once I filter it. But that's what the next step is. Once this cools down, we are going to filter off the solid, and then we are going to wash the solid with dry dichloromethane, which is what the paper calls for. That should give us a solution of benzene, benzaldehyde, and DCN that we would just need to fractionally distill down until most of the benzene is removed. Now, I have serious concerns about the benzaldehyde's reactivity, so I don't know. Daylight is quickly running out here, so I'm not going to have time to do anything more than filter it and get the solution. I've still got to buy the alcohol to make the dinitrophenylhydrazone. So, yeah, we're just going to really hope that it's going to keep overnight. Not much else we can do. Guys, holy shit, man. I was just cleaning up, and all of a sudden, I was hit in the face by the smell of benzaldehyde. It was overpowering. This shit actually worked. It worked. I'm blown the fuck away, and I gotta get it out of here, and I'm gonna try to filter it one more time. There's still some crud in there, but man, I can smell it from here. This shit actually worked. Hot damn. Why does it look like there's some kind of insoluble matter in there? Wait, there's another liquid in here. What is this? Is benzaldehyde miscible with benzene? Shit, I don't actually know. Okay, so I've transferred everything into here. There is some immiscible liquid in here that absolutely reeks of benzaldehyde. I tried separating it in a sub funnel. I could not get it to separate out, which is funny because in the flask it was collected at the bottom. But of course, we lost a little bit of product there, but that's okay, man. This thing still reeks of benzaldehyde, and I'm almost wondering if it's not immiscible. Is it miscible in this? Because if it wasn't, that would explain a lot. Why the smell always seems to be towards the bottom of the flasks. It would just make a lot of sense. I don't know. The sun is almost set. I have run out of time out here. The best I can do is leave it out here tonight. It's supposed to be near freezing. I gotta take my roommate to the hospital to get surgery in the morning. But I'll be back in the afternoon with some methanol and we will wrap this bitch up. I can't believe it. It still worked, all right? I mean, the smell is unmistakable. The only thing that's kicking my ass is fucking methanol or ethanol. I could use either one so that I could prove it while it's still fresh and I've still got it. I've got it sealed up, man. Air is not my friend here, but it's in benzene. It's non-polar. The DCM makes me a little, but we're just going to have to hope and pray that the Lord is with us and that this is going to work. We shall see. Okay, people. So it's the next day. Here is our stuff. I'll bring you over here real quick. I have transferred all of the liquid into a beaker. There is still some kind of liquid that will not go into solution. It's just kind of sitting there as little droplets at the bottom with a small amount of solid matter. Here is the tube that I stored it in last night. You can see it's still kind of coating the walls. I didn't rinse it because well, I was still setting everything up, and I know benzaldehyde is not the most stable thing in the world when it's exposed to air, so I wanted to keep it closed up and just kind of leave it there. I don't want it dissolved in water where it can react with oxygen and do, stuff. I don't want it breaking down. So anyway, we have our Brady's reagent here. This will form a precipitate if you combine it with a ketone or an aldehyde. Aliphatic ketones and aldehydes tend to produce yellow precipitates, whereas aromatic ones tend to produce red ones. This stuff is 2,4-dinitrophenylhydrazine that is dissolved in water, and a primary alcohol, methanol or ethanol, will work. Then you add some sulfuric acid to it. You have to keep the temperature, well, it's around 10 degrees C. It can't go over 20 C while you're adding the acid to the mix of the rest of the stuff. I almost filmed this, but then it was a giant clusterfuck getting the 2,4-dinitrophenylhydrazine out of the bottle because I haven't opened it in years, and it broke. The lid was stuck, and I had to break the bottle with a hammer, so yeah, not really video worthy. But anywho, once you've got it all mixed together, you heat it up to 60 C, and it all goes into solution, and there you go. There's your reagent. I know it works, because I spilled it on my bench, and it reacted with the carbonyls in the wood. But anyway, regardless of that, I am going to prove to you that it works. So what I have here is a little bit of acetone, and this should give us a yellow precipitate because it is an aliphatic ketone. Can you guys see this? Is the piece of shit camera staying focused? All right. This is what our reagent looks like. It's just kind of a yellowish orangey red liquid, and can you see that? There we go. Our nice precipitate showing us that we do indeed have a carbonyl compound. Okay, focus, piece of shit. It's kind of orange. Huh. Oh, who cares? We got a precipitate. That's what I care about. It can be yellow, orange, or red. Now, oh, hello. Okay, what happened there? All right, anywho, and some acetone splashed up on my pipette. This is benzaldehyde. This is reagent grade stuff, so I know it's pure. And, oh, would you look at that? That's not really red. Again, these colors are trends. So long as we get a precipitate, That is what we care about. And we do indeed have a precipitate, and a lot of it, which is nice, because one nice thing about 2,4-dinitrophenylhydrozones, which is what these are called, is that they tend to have sharp characteristic melting points. So now we have a standard reference compound to do a melting point analysis with. Isn't that nice? See, there is a method to the madness here. There we go. Focus, piece of shit. My God. I think it's just because it's such a small, the tube is kind of a small object. All right. We're just going to close that up. Now, another nice thing is we know what color it should generally be. Let's see if we can get any kind of precipitate with this. Oh, God, please give me something. Anything. I'm not terribly picky. Just a precipitate would be nice. No? No precipitate? Nothing? Oh. Is there something here? Okay, wait. It's very hard to tell. Give me a second, guys. This is what's happening here. I think that we have something. Okay. I have serious concerns about how miscible our reagent is going to be with this stuff. But we are going to try it. All right, we may have to vigorously stir it to bring everything into contact. Oh. Yes, kitties. We have precipitate in there. I'm pretty sure. Yes, we do. Yes. Oh, yes. I don't want to tip it the wrong way and dump it out of my hand. The color is not the right color. Why is it the wrong color? What is happening? All right. Okay. Maybe just because it's not pure. Oh. Look, we got a precipitate. That means there is a carbonyl compound in there. It can only be an aldehyde or a ketone. It can't react with anything else. Nothing else that went into our reaction mixture was an aldehyde or a ketone. We had benzyl alcohol in there. There's DCM in there. I don't think this will react with DCM. I hope not. That would suck if that was the case. I didn't think about that. Well, whatever. It won't react with benzyl alcohol. It won't react with benzoic acid unless there is some reaction with DCM that I am not anticipating. I don't see what else it could be. Very curious. All right, let's try seeing what we get here. I'm also not sure that our dinitrophenylhydrazone won't dissolve in benzene, so keep that in mind too. Is it the stuff that's at the bottom? I have been wondering this whole time if that shit at the bottom wasn't benzaldehyde, the stuff that wouldn't go into solution. Motherfucker, I'm thinking this. Oh my God. That's okay. Wait, don't. Melting points. Melting points will tell all. Let's not get our hopes up yet. We don't know anything. Just make sure we got it all. Holy butt fucking shit, people. Okay. That seems like a lot. That seems like a whole lot. That does not seem like that should be right. Okay, guys, here we have it. This is our dinitrophenylhydrazone from the experiment. This is our reference dinitrophenylhydrazone from the reagent grade benzaldehyde. I am going to pop these puppies into the desiccator, take them indoors where it's nice and warm so they can dry out. And as soon as they are dry enough to do so, I am going to do a melting point analysis on these. I know they look a little bit different, but one was made from pure benzaldehyde and one was made from, the experimental mix. So that may have had some influence on it. One also looks a lot more pure than, just look at it. But nevertheless, we are going to soldier on, and we are going to really hope that we can get the same melting point on both of these samples. Regardless of which, again, unless there is some kind of unanticipated reaction between the Brady's reagent and dichloromethane, which I cannot find any mention of on the internet, but barring that, this is proof positive. The fact that we got a precipitate at all, it can only precipitate out with, if there is an aldehyde or a ketone. That's, so far as I know, that's it. So, this already pretty much clinches it that it worked. It can't be benzoic acid, and it can't be benzyl alcohol, and it can't be benzene. So there's, not a whole lot of other options, again, barring some unanticipated reaction with DCM. I posted something about it on YouTube, so, I have found in the past that if I don't know the answer to something and I can't find anything about it online, asking the audience is by far the best way to go. So hopefully you guys will give me some feedback here, and yeah. I may wrap up the video here, in fact, and just do another short little follow-up video on the melting point analysis. I'm not sure yet. I haven't decided. I guess you'll know here in a second, huh?